we should reconsider our views on underground water. The underground water is our source, so we must manage it properly. We'll not be able to pump the underground water flowing into cable tunnels in the near future, because continuous pumping exhausts resources and affects company profits. Trying to clear up even a small problem helps our company.
Thank you, everyone. It's my great pleasure to present a waterproof method for cable tunnels. Before talking about the method, let me explain that our Subscriber Network Research Institute has carried out safety inspections and come up with alternative methods to reduce damage. But the problem of waterproofing was difficult to resolve. Previously, the cable tunnel began leaking a few years after waterproofing. This problem has now been solved. To perfectly waterproof a cable tunnel, you must first understand its structure. In open-cut cable tunnels with concrete, apply a primer, such as asphalt, and then attach a waterproof sheet. Protect the waterproof sheet using bricks and mortar. This completes the waterproofing procedure. With tunnel-type cable tunnels, the bedrock is made into a circle and the drain pipe is inserted. This allows the water to be pumped out and work to be completed on the excavated section. Shotcrete is placed in the excavated section. Then, the non-woven fabric and sheet are placed onto the surface of shotcrete. Drill the lining concrete to complete a tunnel-type cable tunnel. After the work, the drain pipe is supposed to be pulled for a smooth work. However, pump water without pulling the drain pipe, because it to be perfectly waterproof is impossible for now. To complete all the works, like above, would allow perfect waterproofing of the cable tunnel. In reality, however, perfect waterproofing is impossible to achieve, because damage to the materials from steel reinforcing and casts, and the linking parts between sheets, especially ventilating openings, turnout, and vertical holes, allow water leakage to occur. Water that passes through the sheet stays between the lining concrete and sheet and ultimately migrates downhill into the cable tunnel through the damaged parts, cracks, and construction joints. With the existing waterproof method, leakage is prevented by injecting water-soluble epoxy or urethane into the damaged part. However, water continues to flow through other damaged parts of the cable tunnel. This means that eventually the entire cable tunnel must be waterproof. Until now, this was impossible, and safety inspections required the water in the tunnel to be drained. Unlike the existing waterproof method that rejects waterproofing material into the concrete structure, the rear injection method obtains a waterproof seal by injecting into the gap between the concrete and sheet. This not only fills the gap, but also repairs the damaged sheet. It also prevents the water that has already flowed into the tunnel from flowing to lower positions. This serves as a waterproof partition wall. When the waterproof seal is injected into the damaged sheet, it becomes watertight. But if the seal fails to reach the damaged part, the water keeps flowing in. Eventually, the water flows into the cable tunnel through other cracks. If additional waterproof seal is injected, the water cannot flow again. This method is equivalent to the partition wall method that injects air into table. This institute identified 8 characteristics in the performance of a waterproof seal. The first is permeability resistance. This is the basic property of waterproof materials. The second is adhesion. The injected waterproof seal should stick to concrete, even while underwater, to provide effective waterproofing during structural shifting. The third is flexibility. The waterproof seal should move flexibly, along with a structure like expansion and contraction joints when it moves with fluctuations in temperature. The fourth is drainage. The injected waterproof seal should not be drained. The fifth is chemical resistance. The waterproof seal should remain fully functional when exposed to chemicals in the underground environment. The sixth is resistance to temperature fluctuations. The waterproof seal should remain effective at all temperatures. The seventh is constructability. It means that construction should be easy to carry out, even by inexperienced persons. Maintenance and repair work should also be easy to perform when needed. The eighth is an easy maintenance. There should be no problems, even if additional waterproof seal is injected when needed. It is believed that a performance test of the waterproof seal would help eliminate defects and provide long-term waterproofing. The cable tunnel of K-Telephone office shows a serious leakage problem, including slave and wall leakage, infiltration gallery, and influx leakage. Waterproofing is impossible with the current method, so induced drain treatment with copper and rubber plate is being implemented. The materials used for construction are injected waterproof seal, injection materials, and wrench for the formation of the fuel filler, hammer, and drill for perforation, and waterproof seal injector. Remove the induced drain facilities by using cooper and rubber plate for construction. Perforate the concrete to facilitate injection of the waterproof seal. The perforation intervals should be 50 centimeters and injection of the waterproof seal every 100 centimeters. The location of perforations should be in a zigzag pattern centered on the crack. Install an injector at a perforated point. The waterproof seal is injected from the lower part to the upper part. When the waterproof seal injected in the lower part leaks into the next upper part, the injection is completed. The waterproof seal is injected gradually by identifying a leakage in the upper part. Inject the waterproof seal. During the injection, the engineer in charge determines the appropriate injection pressure according to the site situation. After establishing the state of leakage, the engineer in charge determines the position and method of waterproof seal and injection pressure. When the location for injection is decided, concrete is perforated and waterproof seal is injected. Gives the finishing touches to the hull. It was not until this waterproof system was installed that leakage problems of the company's cable tunnel were resolved. Leakage was a problem that started and continued after the original tunnel's construction. The location with greatest volume of leakage leaked more water than an open household faucet. Multiple leaks were present in the wall, including turnout manholes where the cable tunnel turns out. The waterproofing work performed this time has made the site 100% waterproof.